today's problem of the day. Problem of the day, a stock purchase of $2,000 has an average monthly increase of 2%. Boy, I wish I could find a stock that would do that, but there are some out there. You just have to hit them lucky usually. To the nearest dollar, how much will it be worth at the end of a year? So let's take a look at this, and grab your graphing calculators also. We're going to be using those today on figuring this one out, because this one has a lot of stuff going through it. Now, I'm going to talk about, basically this is a compound interest, and also a thing that our investors, and they're people who make good money. It's a great profession. They do financial planners, and they also do dollar cost averaging. I'm going to get that right here for this kind of situation. But it's based on the whole principle of exponential growth. So let's go here, and we're going to put A equals, and I'm going to use a little formula, P and times 1 plus R, which, by the way, these little letters I'll explain to you as we go along, over time. Now, since we're doing monthly periods instead of annual periods, we're just going to go ahead and play this thing out, because it's every month it is increasing by 2%. So T stands for the time element. Many times we say it's just annual, how many years it's working, but we're doing this monthly, and we're giving this 2% every time, all right? So we're going to talk about how many months did this do its compounding over. So I'm going to let T equal 12. R is going to equal, why not, 2%? Yes. And how do we write 2% as a decimal? Not 0.2. Boy, you'll have some great growth if that happens. I wish it would do that. We're going to use 200ths there, all right? Not 2/10, but 200ths. And the P, that's how much we're investing. So that's going to be our $2,000 that we begin with. You say, what's A, Ernie? A is the amount. That's going to be our value at the end of the year. How much is that stock worth? And of course, you may have to pay a few little things out to people for helping manage your stuff. That's something to be careful with. You don't want to have to be paying too much of a, you know what I'm saying, too much expense on that too often on your stocks and stuff, because they can take away a lot of what you get, and 2% here and 2% there in the negative direction, all of a sudden gets kind of slow down that growth rate. So be careful when you are working with a stock investor or a stock broker that you are getting the most bang for your buck. And a lot of that will come from the company or whatever you invest with. I digress. I know you say, well, let's work this problem out, Mr. Roberts. We shall. First of all, let's go with our formula. We know everything but A. We really do. So we're going to put 2,000 right in there for the P. And if some of you are looking for some good investment, and you find one with 2% that's going monthly, you tell me about it. I'd like to put some money in there too, because actually this is really some good stuff. So we're going to put 1 plus, so you put a 1 there, and our 0.2 going right there, and 12, because we're going for 12 months. And the reason we don't use 1 year for this, and everybody, I want to be sure we understand, it's not a 2% annual increase. This is going at 2% a month. It's doing very, very well. So, calculator time. Let's see. Well, first of all, just to convince you guys, let's see what happens if I do just one for 1 month, all right? Let's go with the 1 here. Let's see what happens on the calculator. I'm going to take my 2,000, and I'm going to multiply it times, basically, 1 200ths, 1.02. And let's do that better. Let's put a times sign in there. And we got 1 200ths. There we go. And we'll see what kind of money we're going to have after. We already made $40 in our first month. Now, folks, that's not bad. That's really a 2% increase right there. That's 2%. Now, if I were to play that game again and multiply the 2,040 times, let's see what happens, all right? Because this is what's happening when we compound interest. We now get to make interest of interest. And we're going to say that 2,040 times our 1 200ths. Watch your money grow a little bit. My goodness, we have now increased to $2,080 with a little bit of change. That was nice. That was kind of nice what we picked up there. We picked up a good bit of money, all right? So we can keep playing this game on and on, but let's do it easy. Let's do it the easy way. Let's go back our 2,000, Let me clear this out, but I want everybody to understand kind of what the process is. Compounding means we take what we earn at the end of that month, put it back in there, and then run the 2% right on it too. And once again, it's a growth function because we're getting more money. We don't want to lose money on an investment. It happens, but we want to keep growing. So let's clear what we've got here, and let's go to what I set up with was 2,000 times this 1 200, and we're going to raise it to, let's raise it to the 12th power. We'll put a little parenthesis around that. Maybe it'll work. I don't think it'll like me there. Let me put that there and just put delete on it. I don't think it'll be, I think we'll be fine. That's all the ingredients, right? There's our 1 plus the rate. There's our power. And I put a parenthesis there. We'll see how this works. It may give me a syntax error. If it does, we'll just regroup. Let's see what happens here. Oh, didn't give me a syntax error. It gave me a nice answer. I'm up to $2,536, and it looks like about 48 cents. Now you say, well, wow, Ernie, that was really kind of nice, because for 2%, this number certainly looks a lot better than 2%. But that's what happens when you compound interest. Excuse me on that cough there, folks. Dealing with a little bit of allergies here in lovely East Tennessee this week. And we said to the nearest dollar, we're about what looks like about $2,536. So let's see what that did for us, all right? Now, let's go back to our problem at hand here. I want to say something about it. There we go. There's our value. Calculator takes care of us. That means basically we got some interest upon interest upon interest. I like that. A lot of times we can go to the bank and say, let's compound this thing monthly. And when they do it monthly there, they're going to be dividing that annual rate that you're being quoted like 1% or 2%. They're going to divide it by 12. So you're not going to be getting a really big thing. This difference, remember, was because we were giving you a monthly increase right on the money of 0.02 or 2% or 2/100ths. Every time you're multiplying that, you're getting a little bit of extra money. So, and by the way, why do we put 1 plus that? Because 1 would say it stays flat. If we run 1 to the 12th power, we just get 1, right? And that's what happens. It stays flat. So what you're doing is saying, adding that 2% or that 2/100ths there, that allows you to get that effect of it growing. And it grows, it grows, it grows. Now, my question was, also, it wasn't part of this one, but I want to just hit it while we've got a moment here. What happens when we do 2,000, we get that increase of $536, that was our increase. Let's see what that is as a percentage. Let's take it over our original money we put in there. So let's go with it. 536 divided by 2,000. And that looks like almost a little over a quarter, almost 27%, all right, which is really very nice over a year to have a 20% gain. And there are many times your stocks will go that route. They kind of get crazy. They're volatile. There are other times they can go negative in that direction, which is not so good. But anyway, there's your little practicality of your math. That's why we love doing math here on Mathline, give you a little bit of a taste of it. This one here, we let you increase, and that's some nice thoughts. You said, Ernie, how'd you get that again? We went from 2,000 to what? $2,536. And that's what the worth is after 1 year. Then you're going to pay some fees. Yep, you're going to have to pay your stockbroker and a few other odds and ends. But hey, you're still earning money on the long haul on something like this. Some nice, good money. So there we have it. Good start on our Mathline problem of the day today.